every year that there are some kids that don't know what makes up a deck of cards. So what's in a deck of cards? 52 cards. 4 suits. I lost my black pen. I guess I'll go with green. Okay, so we have 52 cards total, because we don't count jokers. And like in this example, it'll say standard deck of playing cards. The word standard is what tells us we don't count the jokers. Okay, so no jokers. I can't remember who said it, but somebody said 4 suits, which is correct. What are our suits?
Hearts, spades, diamonds.
Hearts.
Spades, diamonds.
Spades.
Club thing.
Club thing.
Club thing.
Diamonds. I like that. Club thingies. They're called clubs. Clubs. I don't think in any of the problems it just gives the symbol, but just in case, obviously hearts are hearts, diamonds are diamonds, spades are the weird ones, like that, and then clubs are almost like the like a 4-leaf clover, but they only have 3. So that's a club. Which ones are red? Which ones are black? Hearts are red. Diamonds are red. Spades and clubs are black. What cards are in each suit?
1 ace, 2 through 10, jack, queen, king.
Which ones are face cards?
Oh, face.
Because they have a face. Aces are not face cards, even though they're a letter like Jack, Queen, and King. They don't have a face on them, so they're not face cards. I think that covers enough. Oh, how many are red and black? What's that? Thank you. 26 red, 26 black. How many 10s would there be? 4. Okay, because there's 10 of hearts, 10 of diamonds, 10 of clubs, 10 of spades. It would happen for each of those, but I'm not going to write that part. It's Friday. Thanks, Hannah. I don't know why I did that. Oh, goodness. 26 red, 26 black. All right. I think that's good. We will reference a standard deck of cards quite often. So if you're not very familiar with the deck of cards, maybe take a picture of this really quick. So if you're doing a homework problem, you're like, oh yeah, this is what a standard deck of cards is. Because they'll just say a standard deck of cards and assume you know all this. All right. So, working with a standard deck of cards. Zoom back in. We're going to deal 1 card. We're going to define event J is that we get a jack, and event R is getting a red card. We're going to make a 2-way table to describe the sample space. So two-way tables, remember we've worked with them before with marginal and conditional distributions. Sorry, my papers are all out of whack now. There we go. So we're going to have one of the events on the side, one is on the top. So let's go with Jack. Getting a Jack, event J is on top. And then when you make a two-way table, I wanted to do the same color. You have the complement. So J complement, not getting a Jack. And then with two-way tables, you should have a total column. And then our other event is going to go on the side. So that'd be getting a red card. And we're going to have red complement on this side. And then we're also going to have a total row. Excuse me. Now with a two-way, yes sir.
What's that T then? T plus
T. Total. TTL. TTL. Sorry. Total.
I was going to say.
I'm lazy. Lazy. I will abbreviate anywhere I can abbreviate. So what I was gonna say, with cards, I'm not super picky about what your grand total is. Most of the time, because you're working with probabilities, your grand total should be 1. But fractions out of 52 are not the prettiest decimals. So if you want the grand total to be 52 cards, that's fine. And so that's how I'm going to make this one. Because in a standard deck of cards, our grand total, the total for both the row and the column, should be all 52 cards. So then, how many jacks are in a deck of cards? 4. So Jack total should be 4. So how many cards are not jacks? Not jacks.
48.
48. Because 4 plus what will give us 52? 48. How many red cards? 26 red cards. And how many not red cards? 26. And notice that 4 and 48 are 52, 26 and 26 are 52. These two numbers are going to add to 4. These two add to 48. Those two are going to add to 26. Same there. They add to 26. So how many jacks are red? 2. So we're going to have the number 2 here. So how many jacks are not red?
2.
How many red cards are not jacks? 24. And how many cards are not jacks and not red? 24. And 2 plus 24 is 26. Same there. 2 plus 2 is 4. 24 plus 24 gives us 48. So that's a two-way table. Shows all the possible outcomes when we're dealing with getting a jack or getting a red card. Any questions before we move on? All right, so part B says find the probability of J and the probability of R. So the probability of J is the probability that when I deal one card, I get a jack. So how many jacks are in the deck? 4. And how many cards total? 52. So the probability that I get a jack is 4 out of 52. What does that simplify to?
2 over 26. 2 over what?
2 over 26, which then simplifies to
1 over 13.
1 over 13. And just because most of the time probability is given as a decimal, let's figure out what that actually is. I don't know that one off the top of my head. That is right. 1 divided by 13. 0.077 if we round. And then the probability of a red card. So how many red cards are there? And how many cards total? And what does that simplify to? And I know that decimal. That's 0.5. So we're going to describe the event J and R in words, and then we're going to find the probability of J and R. So what does J and R mean? What does J mean?
A red jack.
A red jack. J means jack, R means red. So J and R means that we are looking at a red jack. J and R means a red jack. So what is the probability of J and R? Or in other words, what's the probability we get a red jack? Cheyenne is going like this. 2 out of 52. Which would simplify to 1 out of 26. I don't know that decimal off the top of my head. 0.038. Ooh, sorry. Zoom out a little. There we go. Any questions so far? So last time we talked about the probability for A or B is the probability of A, like all of A and all of B. I'm trying to avoid the word and. That's why I hesitated. Probability of A and B is the overlap. A or B is A, B, including the overlap. So for mutually exclusive events, the probability of A or B came from adding the probability of A plus the probability of B. So if we wanted to find the probability of J or R, what would be our probability? What's the probability I deal 1 card and it's a jack or it's a red card? See it?
Would be 0.5 plus 0.077.
So you took probability of R plus the probability of J. Are J and R mutually exclusive? Do they have an overlap?
Yes.
They do. So when we have non-mutually exclusive events, the probability of J or R does not equal the probability of J plus the probability of R. And here's why. So the probability of J, and I'm going to use out of 52, so hopefully this makes a little more sense. 0.077 is kind of tough to work with. So the probability of J is 4 out of 52. The probability of R, I meant to make a P, but I made an R, so it's going to be a little fast, is 26 out of 52. So if getting a jack and getting a red card were mutually exclusive, then yes, the probability of J or R would come from the probability of J plus the probability of R. But since they aren't mutually exclusive, if we do this, I've counted the red jacks twice. Because the jack of hearts and the jack of diamonds are in that 4. And a red card includes the jack of hearts and the jack of diamonds. So when they're not mutually exclusive, if you try to use this rule to find your probability, you're going to end up counting the overlap twice. So for non-mutually exclusive events, or really any 2 events, you could use this rule for mutually exclusive. You need to subtract the overlap or the intersection. And that's what we found in part C, the red jacks. So we would subtract 2 out of 52. That way we don't count the jacks twice, the red jacks twice. So 4 plus 26 is 30, and then we would take away 2. So the probability of J or R would be 28 out of 52. My brain is not on to simplify that one. 14 out of 26, so 7 out of 13. That'd be 0.54.
Yes, because they're over.
I guess another way that might help make it more, I can't find my pencil. I don't want to make this one permanent. The probability of getting a jack when we used our table, that included the red jacks here. And so we had the 4 out of 52. And then when we found the probability of getting a red card, that 2 was included in the probability of red. So maybe that helps you see a little more clearly that we count that 2 twice, which is why we have to subtract it in our rule for non-mutually exclusive events. So the general addition rule for any 2 events, because technically you can use this one for mutually exclusive. The probability of A or B is found by taking the probability of A plus the probability of B minus the probability of A and B. Now, if 2 events are mutually exclusive, meaning they can't happen at the same time, the probability of A and B is 0. So you can use this rule for the mutually exclusive because you would end up subtracting 0. So it might just be easier to memorize this rule if you're dealing with probability of A or B, no matter whether it's mutually exclusive or not. Question? Yes?
In the beginning of the equation where it said the P in parentheses, the J, and then like the U was
The U means or. I mean, it really means union, but in probability we say or. So or that little U, they mean the same thing. And then and the little N, they mean the same thing. We use them interchangeably. Any other questions? All right. So looking down at the next example, this one says, in an apartment complex, 40% of residents read USA Today. Only 25% read the New York Times. 5% of residents read both papers. Suppose we select the resident of the apartment complex at random and record which of the two papers the person reads. So part A says to construct a Venn diagram to represent the outcomes. B is to find the probability that the person reads at least one of the two papers. And probability C, sorry, I saw parentheses in the C. And C, find the probability the person doesn't read either paper. So, before I make my Venn diagram, I'm going to define my two events. So, we have some of the residents read USA Today, some read the New York Times, and some read both. So, I'm going to say U is one of my events, and that means they read USA Today. Do you have to use U? No, if you'd rather use A and B, you can. I tend to pick my letters to kind of make sense, like U is USA Today, so if I'm not, then I don't have to think through A means what and B means what. So I tend to pick letters that connect to the event, but you don't have to. And then I'm going to choose N, and that'll mean the New York Times. So like we talked about last time in math, when we make Venn diagrams, we put boxes around them. So I'm going to start with my box. Maybe if my pen will work. Apparently not. And that is our sample space. So all the probabilities in this box have to add to 1. Then I'm going to make my two circles for my two events. And by the way, my Venn diagrams are never going to be like to scale. I don't even know how to try and make them perfectly to scale. It's not going to happen. So one of my events is U, the other is N, which means in the overlap of the two circles is U and N. I suggest always starting with the overlap if it's given, which for this one it is. It tells us 5% of residents read both papers. So in the overlap, I'm going to have 5% or 0.05. Then if I go back and look at my other percents, it tells me 40% read USA Today. So in my circle for USA Today, all the numbers should add to 40, or 0.4. I already have 0.05. That means 0.35 is over there. Because now between my full circle for you, I have my 40%. 25% read the New York Times. 5%. So over here I'm going to have 0.2 or 0.20 if you want to put it. The entire box rectangle should add to 1. Right now I have 0.35 plus 0.05 is 0.4 plus 0.2 is 0.6. So what percent is outside my two circles? 0.4. And from the other day, we flip back, we had A and B. And I told you that meant outside the circles was A complement and B complement. Yeah. It did. New York Times 25, so I have 0.5 and 0.2, which is 0.25. Okay. So outside the circles would be U complement and N complement, or the people who don't read USA Today and don't read the New York Times. Any questions before we move on?
Why do we have to use this Venn diagram? It's so confusing.
So I have 3 visuals I teach. Two-way tables. I guess they're not really visuals. I call them visuals because they help me visualize my sample space. Two-way tables, which we just did above. Venn diagrams. And then tree diagrams, which we'll do next week. On the AP exam, they may specify which one. So you do need to know how to do all 3. Sometimes they just may say create a visual to represent it. In that case, it's your choice which one makes more sense. But you should know how to work with all 3 of them. So my personal favorite is the tree diagram, but it doesn't work in all situations. So then I have to know what to do for other ones. So you may have a favorite, but we've got to work with all of them. Any other questions? All right, part B, find the probability that the person reads at least one of the 2 papers. What does that mean? They read at least one of the 2 papers. Give me some, like, if I said Zach reads at least one of the 2 papers, what could that mean?
Either
Or, right? So at least one of the 2 papers means or. So we're going to find the probability that he reads the USA Today or he reads the New York Times. I'm going to put the word or too. The U next to the U just really bugs me. So I'm going to put or in there also. Now there is the probability that he could read both, right? We have the overlap. So we're going to be working with this rule for any 2 events. So we're going to find the probability of U plus the probability of N minus the probability of P, U, and N. Nate?
So we're removing the intersection Y.
Why do you think we shouldn't?
Like with both of them?
Hold on. I'm pretty sure I know where you're going,
Well,
but I want to see if you get there.
so my problem is that it says at least one, which tells me that it could be more than one.
Right.
At least one. So why couldn't we include both?
We are including both. What's the probability of you, Nate?
Are we using the probability that it says in the sentence or the probability that we wrote in the diagram?
They're the same.
Well, one of them's 0.4, the other one's 0.35.
No, the probability of you is 0.4. When I find the probability of you, I include everything in the circle of
Okay.
you.
It just clicked. I got it.
Okay. So the probability of you is the 0.35 and the 0.05. So the 0.4, like it says up in the sentence. The probability of N is the 0.05 and the 0.2. or the 0.25, like it says in the sentence. Notice with U, I counted 0.05, and with N, I counted 0.05. So I have to subtract 0.05 because I counted it, I almost said twice. Now this is where I thought Nate was going to go, because when I add these, 0.4 and 0.25, that's 0.65 minus the 0.05 is 0.6. I thought he was going to say, why are we using that when I can just look up here and just add these three numbers?
That should be my next question. Could we not just add those?
So if you're asked to create a Venn diagram, and then you're asked to find the probability, and I guess what I want to say is, I want you to know how to use the rules. I want you to know how to create a visual. Sometimes the visual is going to be part of the problem. Create the visual, then find these probabilities. If you have the visual, you don't need to write this rule out in symbols. Okay? You can just say the answer is 0.6 because it's pretty clear from the visual that the answer is 0.6. If you don't have a visual, it might be helpful to actually write the rule and show your work. Did that help clarify? Okay. Any other questions before I move on? All right, so C, find the probability that the person doesn't read either paper.
That is 0.4.
That is 0.4. It's the part outside the circles. It's also our complement rule, right? So I'm going to put it in symbols, but like I just said, if you can look at the visual and get the answer, you don't have to. But the probability they don't read either paper is the probability of U complement and N complement, which if we use our complement rule is 1 minus the probability of U or N. And a lot of probability problems are set up this way, where you can find the answer to C because you found what you needed in B. So here we do 1 minus 0.6 because we just found the probability of U or N in part B. But like Sam pointed out, 0.4 is up in the visual. It's the remainder of our probabilities outside the circle. I want you to feel comfortable, and that's my goal through the lessons, is you feel comfortable making a visual, finding answers that way. If you don't have a visual, we need to be comfortable using the formulas. Okay? Questions before I flip the page? Sam?
Can I just make the diagram every time because it's easier?
You can try. It's not always possible every time. Because sometimes the answer they want you to find is that like key piece that would make the diagram work. But you can always try, yeah. All right. This one is for you guys to try. I do ask you to practice making both the two-way table and the Venn diagram. Like you heard me say to Hannah earlier, you'll probably have a favorite, but on the AP exam, they may specify which one you have to make, so we have to make sure we can do all of them. And then once you've made your visual, I can't speak today.
You got it.
Do A, B, C, and D. Make your visuals answer the questions.
Okay. If you need help with that, whatever. Do you want me to explain this to you?
No, so
Yeah.
total savings.
Huh?
This.
I'm just making it frustrating to feel so bad.
No, it's all right. So then from there, we need L and C, it's in the
The total for cell phones. Here's a six of it. That's to wait past one. All the numbers in your box should have.
Wait, so that's.
So 0.6 plus what?
You can leave it alone, but
And then what's the total for
I wish.
That's.
and then both of these should add.
And 0.6 plus what?
Sixty.
Oh, to get the total back. And so the difference is 0.2.
It's not,
I got it.
Go birthday girl.
Start,
Go
if it
birthday
has
girl.
the numbers that both start with that, makes it easier. And
Alright, so
Sometimes it has 80%.
Yeah, oh yeah, as I got closer, I saw it.
so then
That's already 0.6.
and that
Total of the land line, is that what?
just for some. Total for cell phone.
yeah.
Then for that one,
So the difference is that.
78.
Oh wait, no.
Both of them.
And that's what
Well, mine is 0.78.
Alright, Haley's putting up the two-way table.
Oh, thank you.
Yeah.
Wait, this is what kind of name?
It's super.
I don't know. Wait,
It should,
why did I do, I looked at this.
Oh,
you're on.
where? Okay.
You took big money instead of big seven. Cause once
And points donation right there.
0.8 should be right. Because the T is the whole circle. T is
Yeah, actually, it's not.
Will you put the Sam's gonna put up a Venn diagram for us.
Kind of.
Oh my gosh, that is circles.
Shut up.
I thought it was like this. Alright, Amelia's gonna do C for us.
I just feel
You wanna do and maybe,
I just did the percents. Do I have to change it to?
no, you're fine.
Okay.
Oh.
That's what's the best emphasis is if you get gifts in the beginning and then
Well then, see, I do her birthday party, that's like all her friends in June. So she thinks her birthday is just all year. I almost forgot, sorry. Jillian's gonna do. I got distracted talking to the birthday kids over here. Will you explain that one where I don't have to show her?
Yeah, so we just ignore the outside part because no one in there owns a cell phone. And since we're only talking about cell phone only, we're also going to ignore the landline and the part where it's landline and cell phone. So we're just going to look at the cell phone. It's point 2, and it's also here in the table, the little one.
Thank you. Alex.
I don't get how 1.2 and 0.02 equals 0.2.
Huh?
Because
That's
0.8.
.18 plus 0.02 equals
Are we talking on the two-way table?
Yeah, it's really tiny.
Yeah.
It's, she has 0.18,
Oh,
0.02 is 0.2. Nate?
So on B, if I ever wanted to actually like represent the equation in the probability language, how would I represent only? What I did is I did P parentheses C subscript only.
I suppose that would work.
Is
Yeah.
there not a
So this is how I would write it.
okay?
I would do the probability of a cell phone, and we use, let's go with T for the traditional landline complement.
Oh,
Having a cell phone and not having a landline.
okay. I like that.
Uh-huh.
A different way.
Seriously?
Math is its whole other language. It, yeah.
Can you check this real quick, please?
What's subscript? The answers are on
He said that's how he wrote it, and I said technically that would be fine. He said he put this probability, that's parenthesis, cell phone only, and subscript means it's the small print down below. But in probability terms, we would say it's the cell phone and the complement of a traditional landline, meaning no traditional landline. But honestly, I'm not going to be super picky about how you write it. If you actually wrote probability of cell only
What if you don't write only? Can you just write probably?
and then wrote equals 0.2, I'd be happy. Okay? And Jillian came up here and just wrote 0.2. And I'm okay with that too. Because the question was right there.
And the diagram.
You wanted me to check something. I was like, I came over here for some reason. All right. Challenge problem.
Already challenged on the
I'm
example.
scared.
I don't know why I called it. Well,
What?
it's a. I love this problem.
That doesn't even. There's too many.
The-
There's too many parentheses.
It's really not a
Honestly,
difficult
seeing
problem.
down, the way you're supposed to write it, it's written.
Say that louder for me.
Seeing down the way it's supposed to be written in parentheses for D helps a lot with the next problem. Because if you hadn't done that.
That way?
Yeah.
Yeah, because that shows up right there. Yeah, it does.
It's confusing, doesn't it?
Are we supposed to make it?
I guess I gave a hint, make a visual. I'm going to make another hint. And by the way, I promise this will be like one of your short answer questions.
On the
exact
test?
question? Not the exact one,
I will
but a
remember it.
similar one. It'll have all of it, but I won't put this little key thing, nor will I give the hint. It'll just be if A or B equals S and then all the other stuff. And I'll ask you to find a probability for me. I'm a Venn diagram person. Do you guys want to try it?
Yeah.
Okay, try it.
Wait.
Oh wait, I said I
With
was
you.
gonna give one more hint. Oh, try it with me?
Yeah.
What hint was
No.
it?
What does sample space mean?
The whole thing.
Which means it adds to
One.
1. So what this statement right here is saying, that says A or B is your sample space. So
Oh.
you have nothing outside the circles. Everything in the circles better add to 1. That's what that statement says, and that's the key to it.
That's confusing.
Wait, I was like, I get it. Then
You don't drop off.
Anyway, we need it back.
I always draw a box, but I suppose, yeah, you
Oh!
want to draw a box.
Remember my foot?
Yeah, I drew a box and then I put 0.
I just yeah. What does she mean by equals 1?
Well, I was just what
Yeah. Not quite.
Sense, sort of.
Oh, shoot, I'm gonna move back that one.
What if I do both?
And then that would change.
Yeah. These are the wrong number.
Okay, good. I was
Is that
like,
correct then?
Everything's good.
so what's the answer to the question?
Probability of A.
Ooh. I guess it's height, right?
Oh. Wait.
Oh,
Wait.
yes.
Okay.
Eric says, to heck with the challenge problem, I'm giving Sam a massage. Sam needed to relax before we could approach the problem.
Oh, you're talking this. Probably keep trying to
Wait, what?
Alright, listen. You don't do this, right?
Where is
If the question has the Dennis's post, right? Because I gave him tradition.
Oh, what do we have? You're good, you're
Put it there. If this is 7,
A.
right? So this whole circle right here is going to be side. We already have 6 people, that's
It's just A.
if it's point
Not
eight,
A. Then would it be just
that way. It's exactly that. If you already anyway, all of this equals together. All of this
not
like
A.
60, that's 80.
All in here.
That's 90.
That's
All
part
that's
of
it. All this is on that 80.
this is part of E.
So it's in the middle.
This one too. This is cell phone over here. So this is point A, all that's
Oh.
this outside, this whole box.
Wait, how does that make sense?
Right? And this is
That doesn't equal 1.
that's what this is. And that's so then
You gotta subtract that, or just gotta figure out this.
What do you mean? You're too smart.
That instead of
Well, I just know that
probability.
I started
the
with
A
You
complement
have to find
Yeah, I just mixed up my numbers. I got
Special.
in theory I got it.
Oh, and this is just one, it's all in there.
and then I did the total of hazard rules. That's surrounded.
Which circle is A and which one is B?
Oh. Probably should specify that.
So it's
kind of like diagram all the way.
So if this probability of a complement is 35, what does that mean?
Anyways, total has to be.
No, you don't.
Because that's what sentence is. This has to be. So
Wait,
for
it's
some,
not A.
the total
So
traditional
A is this circle.
was. Oh, right up here, right? So
Wait, does it add
down.
So this part is all that as one, that's why A
That's
U
what,
B.
yep, that's what that tells you. That shows one and there's
Where I did, so I don't really know that.
No, but I'm on the
point,
table.
not point.
But
Is it this?
we'll
Yeah,
point
oh,
point one is
Yeah.
Yeah, I already did the Venn diagram.
So what's the probability of me?
That's why I got this right. And then for cell phones, they
Hannah, put it on the board for us.
I got it. Michelle, help me, I just mixed up my numbers. No, the table's.
Can I just use the whole thing, or do I need to leave room for a
You can
table?
use the whole thing. I have not seen somebody who has a built-in table.
So then I'm here about this first story.
Everybody started a table.
Yeah, but I can't put.
Tables are
I started it.
The tables are kind of hard.
Yeah, the Venn diagrams are great. So
And also do and.
Two, right?
Yeah.
And of course, see that? That's the like, so do you look at your numbers first, then do then these three are so. Actually, that's how you get that shit. Wow.
and then
It's not when you're underneath each
This one over.
yes,
Forget it.
high fives.
I don't see the table.
Okay, there we go.
I got the table, that's first try, no problem.
Very false.
Wow.
Oh,
Is this right?
Okay, didn't ask me.
For the table?
Yeah.
No.
What, wait, what?
Thank you. All right, so A or B equaling S, your sample space, means that we have 0 out here for A complement and B complement. Probability of A and B complement is this little crescent moon area, so we have 0.25. Now, the weird thing is that A and B complement could also just be written as B complement. A. So when we see A complement, we could also think of it as B and A complement. They're the little crescent moon areas. And since we know that the whole sample space is all the circles, we took 0.25 plus 0.35, which gave us 0.6, to find our overlap here in the middle. So then the question is, what's the probability of B? So you take the overlap in the middle plus this one, and you get 0.75. Questions? All right, so
What is the table?
Michelle, can I steal your paper to put the table up? Thank you. That that would be your table. A complement and B complement would be 0 because there's nothing outside the two circles. So your homework for tonight is the 5.21. I'll put it back up in a minute. I just really quickly want to say this. So we're here on 5.2. That's your homework tonight. Weekend, over the weekend. This one, 5.2. All of what's in that square. Oh my, 57 through 60 are multiple choice. I was going to bring Michelle the orange paper. She doesn't want that.